Ciao friends, and welcome to the Whiteboard. In this episode, we will talk about one-to-one relationships. We will see that one-to-one relationships are a very specific type of relationship that should not be used so often, and sometimes it is used even though better options are available and should be considered. Remember, the Whiteboard is a series dedicated to analyzing abstract concepts in tabular modeling and DAX with the help of the Whiteboard to see these concepts also explained in a more graphical way. However, this is not intended to replace existing content in articles, videos, and courses we have. It is just an additional material you can use to better understand these concepts. So now it's time to go to the Whiteboard. So let's start from this report where we have the sales amount and the shipment amount grouped by brand. The data model that produces this report has 4 tables. Sales and shipments contains the values for sales amount and the values for the shipment amount. But then we have the product table that is connected to sales through the product key column and the product weight table that is connected to shipments through the product code. Now, in order to create a model that can be browsed in my report, we created this one-to-one relationship using the product code that exists in the product table and also in the product weight table. Now we want to focus on the meaning of this one-to-one relationship and the fact that this is always a bidirectional filter. And to do that, let's go to the Whiteboard where I copied the diagram that we have seen in Power BI. So we want to understand the role of this one-to-one relation with the bidirectional filter. In order to do that, let's start from drawing 2 tables that we can connect with a one-to-one relationship and understanding what happens when we have such a kind of relationship. So 1, 1, and the connection this way. Now let's call these tables just X and Y, just because I want to be very accurate in this explanation. And let's say that the column that has the key column that must exist in the 2 tables and that is used in the relationship contains in the table X the values 1, 2, 5, 6. And in the table Y we have 2, 3, 4, 5, for example. Now, if you look at this, this is a completely valid situation. When we define a one-to-one relationship, we have a constraint on these key columns so that the values must be unique in the entire table, this time on both sides. So we cannot have duplicated values in these 2 columns, and this is the constraint we have. But we don't have the constraint to have a value that exists on the other side. For example, because we have 1 and we have 6 that don't exist on the other side of the relationship, the result is that there will be an additional blank row in the Y table to connect 1 and 6. At the same time, if you look at what we have on the other table, in the Y table, we have the number 3 that doesn't exist, and also the number 4. These 2 values don't exist on the X side of the relationship. And so also in this case, we have an additional blank row. So when a relationship is invalid in a one-to-one relationship, we might have the blank row appearing on just one of the 2 tables or on both. It depends on the data. So a one-to-one relationship could actually be seen as a one-to-many relationship when you look at the X point of view, but also as a many-to-one relationship when you look at the Y point of view. So the real difference is that we are applying a constraint on the many side. There could not be duplicated values. And so this is actually what is happening. And the real question is, when do we have to use this relationship? Because actually this relationship could create some problem. So let's go back to the data model and let's focus on what we have in this case. We have to enter into the discussion about what is the data that we have. We have 1 row for each product in the product table. So far, so good. And we have one row for each product code that has an information about the weight and the weight unit measure. I know that in my product weight table, I might not have all the products I have in the product table, but when I have a product, there is only one product there. So there is only one product code at that point. Of course, we don't have a product code with a particular weight and we try to analyze the corresponding product in a product table, I want to see blank, which is exactly the behavior that I expect from the one-to-one relationship. What about the opposite? Is it possible that I have a product code in the product weight table that doesn't exist in the product table? Well, I don't know. You have to know that. In my case, for this specific model, I know that the presence of a product code in a product weight table without a corresponding row in the product table would be a mistake, would be an error. So actually, I don't see a reason why this should be a one-to-one relationship, because technically I want to define a constraint in product code in product table where product key must be unique and product code must be unique. But actually, product weight is just more like a detail, an optional detail I have for this table. So in order to figure out whether my assumption is true, you could try to change this to a one-to-many, in this case to a many-to-one, because we consider the product weight on the many side. And if we try to create the relationship this way, and it is accepted, it means that we actually have a situation where we could use this. And if I go back, and by the way, for my modeling, this relationship is probably good enough, it is single. And if my only goal for having the product weight table was to be able to connect the shipments table, well, that is something that still doesn't break my report. Now, of course, if we think about this model, and if we go back to the whiteboard, let's say that we have, and let's focus on another example. So we have a situation where we have the product table, and we have, sorry, I don't want to do this, product table, and then we have like an extension of the product table, which is the product weight. So in our idea, if my goal is to just have an additional version, an additional extension, like optional feeds for this table, well, the best way to obtain the result that we achieve, so what we are using is a one-to-one relationship. But a better way to obtain the same result would have been to create a single product table where the values coming from the product weight are just a few columns. So imagine that these are the columns that we have here in this area of the product table, and these are the columns coming from the product table. What I would expect is that for every row in this area that don't have a corresponding value in the product weight table, I should have just blanks in this area. So this should be blank. If I populate a table this way, if I create a product table that actually have one row for each product key and for each product code, and I connect the product code to the shipments table, it will work. So if I have, in this case, the product key is a column and the product code is another column, then my sales table and my shipment table will be connected using the code and the key. So this is the key, this is the code. It just works. It means that I have a unique constraint in two tables of the product table, in two columns of the product table. The product key must be unique and the product code must be unique. Of course, this implies that you need a valid product code for each product in the product table. So there is only one case where we actually want to use a one-to-one relationship. And it is the case where it is completely normal to have products that don't have product weight and product weight rows that don't have a product, and we want to keep the data this way using probably different keys. At this point, this could be a requirement. if the two elements could be combined using a key, but actually they contain other keys used to connect other tables, then it could be complex to create a single table, or maybe it's just too expensive. But whenever you can use this approach, well, you should think about doing a single table, preparing a single table in your model, avoiding the one-to-one relationship. Why that? Because when we use a one-to-one relationship, like in this case, we introduce a bidirectional filter. A bidirectional filter could be dangerous, could introduce ambiguity. It's not the case for this particular model. So in this particular model, it would be good enough. It will not generate big issues, but it's always something that you have to pay attention to. So that is the behavior of the one-to-one relationship. Something that should be very rare to find in your report, but could happen just because you import the data and you find that the relationship is automatically detected as a one-to-one. Sometimes this is wrong, and what you really want to do is a one-to-many, understanding how the distribution of data will change in the future. Also avoiding loading data when you will try to import multiple rows with the same key on the many side of a table that has been initially identified in a relationship as a one-to-one just because you had a small amount of data. So we have seen that the one-to-one relationship is a valid relationship that is always bidirectional, even though the bidirectional filter is not the biggest of our concern. What should be paid attention to is the fact that the one-to-one relationship is actually a 0 or 1 to 0 or 1 relationship that could generate blank rows on both sides of the relationship. Is this really what you want? Sometimes it is not. Sometimes you just want to consolidate the two tables into a single table, having more control on the data quality for your model. So I hope that you enjoyed this episode of the Whiteboard and enjoy DAX.